Okay, this is the final review, number 5. It has some statistics on here. So go over a few of these. So we already have the equation given right here, the line of best fit. Okay, and these are the same thing, just one's a fraction and one's a decimal. All right, so they're asking, what does the negative 1/2 represent for the slope? So just remember that slope is rise over run. All right, which means the rise is the up and down, the y-axis, the x is the run. Okay, so we have -1/2, and we just want to look at the units of the y for the top. So that's going to be feet of water. Okay. Feet of water, called H2O. And time in, looks like hours. So hours. So the trick is to find the meaning is to look at the units. So this means it's going to go down, right, -1 foot. It's going to go down 1 foot of water for every 2 hours. Okay. So water in the tank will reduce 1 foot every 2 hours. So that's the key for describing the meaning. Anytime it says what the meaning is, look at the units to figure that out. Okay. Next, it's actually, there's some directions missing. It should say which ones are true or false here. So we just look at the graph or use the equations and we can decide whether A, B, and C are true or false. So it says the depth of the water of the tank starts at 1/2 a foot at 5 p.m. And no, at 5 p.m. it looks like it's 2.5 feet. So that's false. Okay, and the tank of water starts at 1/2 a foot at noon, and no, it starts at 5 feet at noon, so that's false as well. Okay, the average depth of the water tank goes down 1 foot for every 2 hours. Okay, that's what we just set up here, right, for number 1, so that's true. That's what the slope means, goes down 1 foot for every 2 hours. And at noon, the tank water is 5 feet deep. So at noon, yeah, it's at 5 feet. See that? At noon, 5 feet. So that's true as well. Okay. There we go. All right, now we can predict the depth of water at 3:30. So let's go back to our graph here, and we can look at 3:30. It'd be right here. So it looks like it'd be about 3.25. It's like kind of right in the middle of 3 and 3.5. So 3.25. Okay, which we can round to, oh, no, here it is, 3.25. All right, that's using the graph. Now they also have the equation. So you can plug in 3.5 into the equation, and that will also give you the same answer. So either by the equation or the graph, you'll get the same approximate answer. Okay. Looks like we got a graph of length of beard in millimeters. Okay, so this is the length of the beard in millimeters. Okay, it's on the y-axis. Right, same idea, just more practice of the same thing. So what does the equation, what does the 2.5 represent? Or the 5/2 is another way of looking at it. So it's 2.5, remember it's rise over run, so it's millimeters for every week. And when we say week, for every week, per week, that means 1 week. So it looks like it's gonna, this is positive, so that means it's getting 2.5 millimeters longer for every week. So you could say something like the beard is growing 2.5 millimeters each week. Okay. So here, yeah, not talking about sleeping, so that's going to be false. Okay, Rickman grows an average of 5 millimeters every 2 weeks. So yeah, if it's growing 2.5 millimeters per each 1 week. Okay, so Rip Van Winkle's beard grows an average of 5 millimeters every 2 weeks, kind of similar to the last problem. If it does 2.5 and 1 week, that means it will do 5 every 2 weeks. Okay, 5, 2. Okay, so slight difficulties. So yes, that's going to be true. All right. And so can you grow an average 2 millimeters every 5 weeks? Well, no, because 2.5 takes 1 week, so 5 weeks will be a lot more than 2 millimeters. So that's false. And then 2.5 millimeters every 10 weeks, no, we still know that it's 2.5 every week, single week. So that's false as well. Okay. What does the 10 represent in the equation? That's a y-intercept right here, which is the point 0, 10, where the x, right, the 0, is talking about weeks. So that's basically at 0 weeks, right, 0 weeks, the beard is 10 millimeters long. So another way of saying that, he started, when we started keeping track here, it was already 10 millimeters long. So at the beginning, let's see, say, he started keeping track at 10 millimeters. Not that it started at 10 millimeters, because it has to start at 0, but that's when he started keeping track. Okay, again, some more true-false here. His beard grows an average 10 millimeters every 2.5 weeks. We kind of already went through these. So 10 millimeters every day. No, that'd be way too long. 10 millimeters before I fell asleep. No. And the first week grows an average of 10. No. Okay. All right. And predict the length of the beard after sleeping for 17 weeks. Okay, let's go 17. Where would 17 fall on this? So here's 15, so 17. Try to go straight up. And then, so it looks like a little over 50 and below maybe 55. Okay. So we could say maybe 52 millimeters, right? And you can also use the equation. So you can plug in 17 into here. It'll be 2.5 times 17 plus 10. And that'll give you a good estimation also. So let's calculator. There we go. So 2.5 times 17 equals plus 10 would be 52.5. So I estimated from the graph 52. So 52.5 millimeters. So pretty close. And I guess we were rounding up to 55 if it was multiple choice. Okay, so that's it for the statistics using the line of best fit. Okay, so let's go back and do a little review of everything. Find some x-intercepts. All right, so we can do this a couple ways. See if we can do by factoring. So what two numbers multiply to 1 times 7 and add to -8. And looks like that will work because -7 and -1. Oh, maybe not. -7, -1 is -8. Oh yeah, that works. So this is going to factor to x minus 7 and x minus 1 equals 0. And if this came out to be prime, meaning you couldn't find the two numbers, then you'd have to go to either completing the square or probably quadratic formula. But try factoring first, because when it does work, it's the fastest. But it doesn't always work. So we get one x-intercept of 7 and the other x-intercept of +1. 1 and 7. There we go. All right. Which is true about the transformation of the parabola? Okay. So -2 and -3. Now, quick reminder, for absolute value, or for quadratics anyway, works the same thing. Works the same way here. We could change this to be a quadratic instead of absolute value, but it does work the exact same way. Right? That the h will move it left and right, but it moves it kind of opposite. The positive moves it left, and the negative moves it right. So you just have to remember the vertex is actually the opposite or negative of whatever's inside, but the k is still normal and moves it up and down. Okay. So right here, this actually, the -2, it shifts it to the right, and the -3 shifts it down. Okay. So this is going to be shifted, let's see, or translated not up, right? It's going to go down because it's -3, right? It's shifted to the left. No, it's shifted to the right because negative and the inside means to the right. And the vertex is located at, 2, -3 because, it's the opposite. Since this is negative, we know the vertex is actually positive 2, -3. So that's it, correct. And it doesn't open downward because the coefficient in the front is +1. When there's no number, it's automatically +1. And you can see here, +1 or positive anything opens up. If it was negative, that opens downward. Okay. Let's do a little completing the square. So this is like the first step for vertex form, right? So when we do this, okay, you're usually taking half of this b, right, which is -5, and you're squaring it, right? And the -5 squared, right here, that's the number they're talking about for A, B, C, and D. So -5 to the second does equal 25. That's what you're adding to both sides. Okay. Write the function right here in vertex form. All right, so we got to go through and do a little bit of work here. Bigger. All right. So let's walk all the way through translating the vertex form. Okay. I'll leave this little little space here. Okay. So again, set it up this way. So we'll take half of 6, which is 3. Right. That's going to cause us to add 9. Right? Because 3 squared, the 3 we just added, is going to be 9. And to balance that out, we're also going to subtract 9. Right? So these will always match. One's going to be positive, one's negative. And then 3 minus 9 will equal a -6. And you can see that answer right here. Okay? So the vertex, remember it's opposite, so it's actually at -3, -6. Axis of symmetry, that's actually this right here. So it's x equals -3. The y-intercept we can get from the standard form. Okay, so y-intercept is going to be 3, and we'll use that c equals 3, or you can write 0, 3 as the y-intercept, and then we can go ahead and graph everything. So let's see here. We got the vertex is -3, -6, so that's right about here. We know the axis of symmetry is right down the middle. Okay, right here. It's opening up. This is a positive A. And we know the y-intercept is 3. Right? 0, 3, so I know it's right here. And because of symmetry, I know it's also 3 to the left of the line of symmetry also. So there's a rough graph right there using the vertex and the y-intercept to graph. And we could use a table and also find the x-intercept if we want to be more precise. Okay. All right. Let's do a little bit of graphing. Okay. So now we have absolute value. So this is shifted 3 to the right from the center, so we know that's going to be -3. So just like the parabola, it moves left and right opposite sign. Okay. And it's opening upward, right? So we know it's not going to be negative. So see those negatives? That means it opens down. So it can't be those. And there you can see we have the -3. So C. Similarly, here we know it's opening down, so it has to be one of these two negatives. It can't be there. So because of those negatives, it's opening down. I know it has to be one of those two. And since it's moved 2 to the right and 1 up, 2 to the right will be x plus 2, and then the up 1 will be a plus 1. So that will be, let's see, B. And it has the negative in front because it's opening down. Okay. Same idea. Oh no, these are roots. Okay, so we're doing some roots here. Opening up, so it's going to be a positive A. So you can see there's some negatives here. So that can't be it. Those both open down. No and no. Right, you see the roots here. See, it's -3 and -1, so it's going to be opposite signs. Right, so it's going to be x plus 3 and x plus 1. How come they're opposite? It's not because of this up here like we did with absolute value. It's because we're kind of working backwards. So if we're going to solve this, x plus 3 equals 0, that's where the -3 comes from. So in order to get -3 right here, it actually has to be an x plus 3. And same thing here. In order to get x equals -1, the factor has to be x plus 1. So we get D. And for the same reason on the next one, 17, if we have a -5, we'll have x plus 5, and then an x plus 3. This is opening upwards, so I know this is positive as well, so it can't be the two negatives. It has to be the one that's opening upward with plus 5 and plus 3. Okay, let's do a little bit of determine the number of solutions. Okay, so that's going to be the discriminant. Okay, and that is b squared minus 4ac. We're looking to see if it's negative, is it 0, or is it positive? If it's negative, there's no answers. If it's 0, there's one answer. And if it's positive, there's two answers. Alright, so we can figure that out. Let's calculate it. So we're going to use, for A, we're going to use 1. B is -4. C is positive 4. So for my b squared minus 4ac, I'll have -4 squared minus 4 times 1 times 4. So it's 16 minus 16, which equals 0. So 0 means there's one solution, one real solution, and that's also the vertex. Anytime you have one solution, the solution is also the vertex as well. And just to check that out why, you can see, yeah, if the vertex, if you have one solution, it's when the vertex is the only point crossing the x-axis. It's the only way to get one answer if it's the vertex that's touching the x-axis. Alright, and that looks like the end of the review. Alright, so just like all the others, make sure you can do these by yourself with no help from beginning to end and get all the right answers. So don't just copy them down and say, I'm done. Okay, you have to know how to do these on your own and be able to explain it as well, so that when the numbers are different on the real final, you'll still know what to do. So you'll say things like, yes, since it's moved to the right, it's going to be negative. So you know if it's moved to the right 5, you'll know it's going to be a -5. So you must know how to do these on your own and explain them. Okay, good luck.